This is going to be a Taylor series example. So it says the Taylor series of the square root of x about x equals 1 is given by this function, and they want us to figure out what the coefficients are. So for me, when it's Taylor series, I like to go back and just write down the formula straight from the formula sheet. A lot of people forget that the coefficient is going to involve both the derivative and dividing by a factorial. So to make sure I don't leave that off, I'm going to copy this from the formula sheet. So it's f of a plus x minus a times f prime of a plus x minus a squared over 2 factorial times f double prime of a, and then it just gives me a dot dot dot. Okay, after that I'm on my own. So the only difference between the Taylor series and the Maclaurin series is that the Maclaurin series is centered around 0, so that all of these become 0. Okay, and so I'm going to start with the original function, which is the square root of x. If I'm taking the derivative, it would be easier to call it x to the 1/2. I'm going to have to evaluate all of these at 1 because they said it's centered around 1, when a represents what it's centered around. Okay, so I might as well, as I go, f of 1, 1 to the 1/2 is 1. And so my first derivative would be 1/2 x to the negative 1/2. And that's the easiest way. I'll just leave it like that for now. I'll rewrite it when I'm trying to actually substitute in 1, but we'll just go down for a minute. Just go ahead and make this negative 1/4 x, power goes down by 1. Okay, and it looks like I'm going to need to the third power, so third derivative. So negative 3/2 times a negative 1/4, so a positive 3/8, power goes down by 1. Okay, and I'm evaluating all of these at 1, so it's easier for me to move the negative exponents. So move the term to the denominator and make the exponent positive. Okay, so this would be the same as 1 over 2 square root of x. So if I evaluate at 1, I would just have 1/2. Okay, and this little guy right here would be negative 1/4. And this would be x to the 3/2 in the denominator, which would be the same as raised to the third and take the square root. Remember that the top number tells you what you're raising it to, the bottom number tells you the root. Okay, and so if you substitute 1 into here, this would be f double prime of 1, and that would just be negative 1/4. And then finally, the third derivative evaluated at 1. And, well, you could just make this. I guess I could have moved it around a little bit here. It's just going to come out to be 1, but you'd have 3/8, and then you could make this 1 over x to the 5th, and then you're taking the square root. Okay, so let's just make this 3/8. Okay, raised to the 5th and taking the square root. But when you put in 1, raised to the 5th, take the square root. That's just 1 anyways. Okay, so f triple prime of 1 will just be 3/8. Okay, but one mistake I've seen commonly is people then try to report this as a naught, a sub 1, a sub 2. But remember that if you look at the formula, this is going to be your a naught. And then if you look, this is your a sub 1, and if you look, your a sub 2 will be right here. Okay, so you have to remember to include that part. Okay, and so let's just go ahead and write it out. I think that wouldn't hurt anything. So f of a would be f of 1, so this would be 1 plus x minus 1. F prime of 1, so 1/2. And then this one would be x minus 1 squared. And here you would have your f double prime of 1, which was negative 1/4. But you need to remember to divide it by 2 factorial. Okay, and then it doesn't tell me about the next one, but I know it's x minus 1 cubed f triple prime of 1, which would be 3/8, and following the same pattern, I need to divide by 3 factorial. Okay? So if we look, our a naught is 1, our a sub 1 is 1/2, this is our a sub 2, okay, and 2 factorial is just 2, so this is just 4 times 2 in the denominator, so you would have negative 1/8. Your a sub 3, it's a little more to that, but you've got 3, and then this is 8 times 3 times 2 times 1, and you can cancel the 3's, and so then you would just have 1/16. Okay, and that's all they asked you to do. You could have left it written out as a polynomial if that's what they had wanted, but they asked for the specific values, and they are trying to make sure that you remember those factorials. Okay? Now it says hence or otherwise find these values. So when you look at that, really the otherwise is just L'Hopital's. Okay, so you can kind of see if you substitute in 1 right here, then you'd have 1 minus 1 over 1 minus 1, 0 over 0, a good old L'Hopital's. Okay, now it's saying hence, which means that probably whatever you just did would be useful. Okay, and so square root of x we figured out was equal to this nice expansion that we have here. So what I'm going to do is substitute in for the expansion. Okay, so the square root of x would be the same as 1 plus 1/2 x minus 1. And then we're going to have minus 1/8 x minus 1 quantity squared. And then we're going to have plus 1/16 x minus 1 quantity cubed. Now you need to indicate to them that you know that's going to keep going. Okay, so a little dot, dot, dot there. So that would be your approximation for the square root of x. And then from there, you need to subtract 1. Okay, and then in the denominator, you have x minus 1. Okay, so what's nice here is the 1 minus 1 cancels. And so you're dividing each one of these terms separately. So we still want the limit as x approaches 1. But we have the limit as x approaches 1. And if you divide this term by x minus 1, okay, so you would just, that would cancel. You would have 1/2. If you divide this term by x minus 1, you'd have minus 1/8 times x minus 1, because one of those is canceling. And then the next one plus 1/16 times x minus 1 quantity squared. And you're indicating that you know what goes on in that pattern. Now, the limit as x approaches 1, that's going to, if you put the substitute in 1, that'll make this 0, that'll make this 0, all the rest of the remaining terms 0. So this is just 1/2. Okay. The only other way would be to do L'Hopital's. Okay, so it never hurts to have a quick little review of L'Hopital's. If you substitute it in here, you would have the square root of 1 minus 1 over 1 minus 1. Good old 0 over 0. Okay, and so then you know that would also be equal to the limit as x approaches 1 if you took the derivative of the numerator and denominator separately. So this little guy right here is x to the 1/2. So if you took the derivative, it'd be 1/2 x to the negative 1/2 minus the derivative of 1 is just 0. In the denominator, the derivative of x is just 1, and minus the derivative of 1, which is just 0. So now this would just be equal to the limit as x approaches 1 of 1 over 2 square root of x. And if you substitute 1 in right there, you would still get 1/2. So either method is fine.